Everything around you is made of tiny things called atoms. Think about the chair you're sitting on, or the air you are breathing, or even your own body. It's all atoms. These atoms don't just sit still. They are constantly interacting with each other. They bond together. They break apart. They swap partners. When atoms rearrange themselves to form new substances, we call that a chemical reaction. It's like a grand microscopic dance where atoms are the dancers. It's an incredible ongoing process that makes everything in our world possible, from baking a cake to launching a rocket into space. Consider this. You mix vinegar and baking soda. What happens? It fizzes and bubbles. That's a chemical reaction in action. They are turning into something new. Carbon dioxide gas, water, and a type of salt. And one of the most important, most fundamental types of chemical reactions is something called a redox reaction. It sounds complicated, but I promise it's something you see every single day. So what is this redox thing? It's a name that is actually a combination of two words, reduction and oxidation. They are partners. They always happen together. Let's break it down. Let's start with the basics. The key is tiny, negatively charged particles called electrons. In many chemical reactions, atoms can either lose electrons or gain electrons. It's all about where the electrons are going. Remembering which process is which can be tricky. Chemists have a clever mnemonic. All you have to do is remember this phrase. Leo-ger. Leo, loss of electrons is oxidation. Ger, gain of electrons is reduction. So Leo gives, Jar takes. A friendly lion reminding you which is which. Now let's look at a real-world example of a redox reaction. Rust. Think of an old bicycle, a chain, a nail left outside in the rain. Over time, that shiny, strong metal turns into a flaky, reddish-brown substance. That substance is rust. On a microscopic level, iron atoms lose electrons and oxygen atoms from the air take them. According to our mnemonic, the iron is being oxidized, Leo. The electrons transfer creates a new substance, iron oxide, which we call rust. The result is weak, crumbly metal. This is why rust is a problem for structures and vehicles. It's all because of that unstoppable transfer of electrons. Let's dive a little deeper into this idea of electron exchange. This is the heart of every redox reaction. Atoms exchange electrons to reach greater stability and release or store energy. Electrons move from places where they are less comfortable to places where they are more comfortable. Think of it like a waterfall. Moving downhill releases energy that can do work. This movement of electrons releases energy that drives processes and powers devices. The substance that causes oxidation is called the oxidizing agent, the electron grabber. The substance that causes reduction is the reducing agent, the electron giver. That sounds odd. The oxidizing agent itself is reduced, and the reducing agent itself is oxidized. Where else can we see redox?